Here, a fission reactor of 1000 megawatt power is given. It's using half of its fuel in 5 years. We are supposed to calculate how much is the initial mass amount. So the reactor is not operating 100% of the time, only 80% of the time. And the energy is only coming from fission of uranium-235, no other forms of energy. So power is given as 1000 megawatt, 10 to the power of 6 total, 10 raised to 9 watt. So this is coming from half of the fuel. And it's operating for a time of 5 years. Years you need to convert into seconds. 1 year is 3.16 into 10 raised to 7 seconds. So 5 into 3.16 into 10 raised to 7 seconds. On calculating, it's coming to be 80% time only. So you have to calculate 80 by 100 of the total time. Time is expected to be 5 into 3.16 into 10 raised to 7 seconds if it's operating complete 5 years. Since only 80% of the time is operated, it will be 80 by 100 of the total time. That is calculated as 1.264 into 10 to the power of 8 seconds. Now you have power and time, we can calculate the energy. So energy is power into time, or power is energy by time. So power is 10 raised to 9 and time is 1.264 into 10 raised to 8 seconds. The total energy is 1.264 into 10 raised to 7 joules. It's a simple concept. We need to know energy released from one atom of uranium is always 200 MeV. That will not be given for the exams. We are supposed to learn energy per fission of uranium-235 is 200 mega electron volt. We need to convert again into SI unit. 200 mega is 10 to the power of 6. 1 electron volt is 1.6 into 10 raised to minus 19 joules. So overall will be 3.2 into 10 raised to minus 11 joule is the energy from one uranium atom. Now the total energy will be always energy from one atom into number of atoms. So if you want to find the number of atoms, it would be total energy by energy from one atom. So total energy we already calculated. Energy is from one atom also we have. So substitute those two values. 1.264 into 10 raised to 17 is the total energy. 3.2 into 10 raised to minus 11 is the energy per one atom. Energy per atom. So the total will come as 3.95 into 10 raised to 27 atoms. So this many atoms will give you 1.264 into 10 raised to 17 joules. Now we need to go to the mass. For that Avogadro concept, 235 gram of uranium will be equivalent to 6.02 into 10 raised to 23 atoms. This many atoms will have totally 235 gram. So one atom will be 235 by 6.02 into 10 raised to 23. So mass of one atom of uranium will be, since 235 grams is equal to this many atoms, one atom will be divided, 235 divided by 6.02 into 10 raised to 23. This is mass of one uranium. We have these many atoms of uranium. So total mass of those atoms. Mass of one atom into number of atoms. 3.95 into 10 raised to 27 number of atoms. This is mass of one atom. You calculate to be 1.543 into 10 raised to 6. This is in grams. This is only from half of the fuel. So if you want to find complete fuel, you need to multiply that by 2. That also in grams. You convert into kg, divide by 1000. This is the final mass calculated that was initially present.